Hey boys and girls, Mr. McCauley here. I'm just going to go over the chapter 11 3D geometry review. It has to do really with these two types of shapes. They are prisms and they are pyramids. So what is a pyramid? Probably let's start with that one. Pyramid, of course, has all these triangles that come up to a very point. The vertex at the very top is made by a whole bunch of different lines. But the important thing about a pyramid usually is the shape that's at the base. This is an octagonal pyramid because it's got an octagon on the base. And then you've got all these pyramids going up to the top. A pyramid only has one base shape, and that's at the bottom, the base. If I look at a prism has a shape on one end and the exact same shape on the other end. So it's got two congruent shapes at the base, and then it's got all these rectangles. Hey, they can also be squares too, but squares are rectangles. Then it's got all these rectangles around here. How many rectangles does it have? Well, if this has 6 sides, you end up with 6 rectangles. If it had 8, you'd have 8, etc., etc. So if we're looking to fill this in with some of the definitions, what is a prism? A prism is a shape. So here's our prism. It's got two, I'm going to use the word congruent, but you can also say the word same, base shapes. And the rest are all rectangles after that. But a pyramid has one base shape, and then it has lots of triangles, and that goes up to a vertex at the top. What's a face? A face is the flat side. Let me just check to make sure that's working. Yep, flat side. An edge is when you have two faces come together. And I'm doing this pretty quickly, but you can fill it in and do a better job than I'm doing. Two faces come together. Then you get this line with a two face. There's one face, there's the other face. The edge is the line in between. And a vertex is a fancy word for corner. And it's when different faces come together. Most typically, you've got 3 faces come together here, but in a pyramid, you can have lots of triangles coming together to form a vertex. Now, these shapes here are nets, and a net is a shape you could use to build a 3D shape. This, of course, is the cube. This is a rectangular based prism. This is a triangular based prism. Now, very often, if kids are going to make a mistake, I said this so many times, it's going to be over this shape. People see triangles and they say, oh, it's got to be a pyramid. This is the one time these triangles do not form a pyramid. They form a triangular prism. This is a typical Toblerone bar. Excuse me. Here is, again, I see 2 base shapes and then a number of, in this case, squares, but squares are rectangles, a number of rectangles. So this is a hexagonal prism. This is all triangles. So this will be the base here. So this is a triangular based pyramid. And finally, we have a square-based pyramid here. And you can see the base here, and then you've got 4 triangles that lead up to it. Oh, maybe a marker was not a good idea. Live and learn. Let's go to pen instead. On this, what I'm asking students to do is there will be a table of something like this where you will have to count the edges and the faces and the vertices of something. Let's just do one together. Let's do the hexagonal prism. So first of all here, what shapes are on here? Well, I see a hexagon, and then there's a rectangle, and then I just have different versions of that. So there's only two different shapes on here. How many faces? When I count faces, what I do is I count the top, then I count the bottom, then I count all of them around. So there's one here, that's two, and there's 6 around here. So 6 and 2, that makes 8 faces. For edges, again, I'd like to hold it like this. I count the edges up here. There are 6 edges here on the top. There are 6 edges on the bottom, and then each one of these is an edge. So the 6, 6, and 6. So there's 18 edges here. And vertices, we count the corners. So there's 6 corners here and 6 corners on the bottom. There is 12 altogether. So it's kind of a bit of a pattern. The base has 6 corners, 6 sides. And then the edges is 18, which is 3 times 6. And the vertices are 12, which is 2 times 6. So for each one of these, there's kind of a bit of a pattern. Let me get the shape here. Oh, here we go. Hexagonal pyramid. So what shapes are involved here? Again, there's a hexagon and there are a number of triangles. There's only 2 types. How many edges are there? In the base, there are 6 edges here. And then I count edges coming up. 6, 7, 8, 9, 10, 11, 12. There's 12 edges. Oh, edges goes here. How many faces are there? 1 base, and then 6 triangles makes 7 faces. And finally, number of vertices. There's 1 corner here and 7 around here. So that makes 6 around here. So that makes 7. Oh, I really wish I hadn't used marker there, but hey, live and learn. Now, sketch all of the 3D shapes you can with these shapes. Well, there would be, I could do a cube. I could do a rectangular prism. I could do also a triangular prism. So those are 3 prisms I could make if I had these shapes. If I was doing triangles, if I was doing pyramids, I could do a square-based pyramid. Might look something like this. I could do a rectangular-based pyramid. Might look something like this. And I could make a triangular-based pyramid. So there's probably 6 shapes, 3 prisms, and 3 pyramids I can make with these shapes. On this section here, I'm going to ask students to do some 3D drawing of shapes. There's different ways of doing it. If I was doing a rectangular prism, it might look something like this. The method I use is I pick 3 corners, and then I draw a line exactly the same on the same angle, and I can make that into the shape I need. There we go. I know Mr. Martinowski likes this method, where he goes like this. There's another way of doing it. So I'm going to ask students to be able to draw the shapes here. And then 3 different nets for a cube. This is what the classic net might look like. I could cut that out and fold that into the cube. Of course, that looks like a cross. But what are other ones that, where else could I put build the different shapes to make a cube? Now, if I say I want to leave this part intact, then that really means I need to move these flaps around. So this flap here can go here, can go here, here, or here, and the same on the other side. So if I move this guy to different spots, I will still be able to get a cube. So for example, if I draw the backbone of the 4, then I could put 1 flap here and 1 flap there, and that would still be a cube when I made it. But if I put 5 in a row, 1, 2, 3, 4, 5, and 1 here. That will not do. This will not work. So the way I think about a cube is I have the backbone of 4, and then these guys can go anywhere I want. And I could build a cube that way. Now we're going to move over to the measurement part. And the measurement is going to either be a volume or capacity. And it's going to be also, I'm going to talk about the weight, or more commonly in science and in math, we'll say the mass of things. So what are things you'd measure in milliliters? Well, those would be small things like a can of pop or a juice box or a water bottle. What would be in liters? Bigger things like, I don't know, a bathtub. How much it would hold or something like that. Or a 2-liter bottle of pop, right? And what are things you'd measure in grams? Maybe an eraser, or how much spice you have about something. What's something you would weigh in kilograms? Well, people. And other heavy things. One of the things you have to remember that is a kilogram weighs 1,000 grams, and a liter is 1,000 milliliters. So if I have 2.5 kilograms, that means I have 2,500 grams. If I have 7.9 liters, I'll do a capital L for liters. We usually do small l just to make it easier to read. Then that is really 7,900 milliliters. For grade 5, one way you can measure volume is via something called displacement. Basically, it means if you have some liquid in something and you put something in there that sinks and the water rises, you can measure the increase and you could figure out what volume of the original item was. So let's say here, I'm starting at 600 milliliters is the start, and the water went to 125 milliliters, or whatever that liquid is. If I subtract this, that means that whatever the object was that I put in there, it has a capacity or a volume of 65 milliliters. You can do different calculations or different problems by doing something like that. Okay, the very last thing we have to do is we did some weighing with a triple beam balance. So if this is what it looked like, what would the weight be of the object on a triple beam balance? A triple beam balance has 3 different beams with things you move. And you always, when you're measuring it, you work from the heaviest to the lightest thing. So for this one, I see that this guy's on 400, this guy's on 60, and this guy's on 2. So it was 642 grams. Again, this one's on 200, this one's on 10, and this one's on 9.5. So I do 9.5, and I have to make sure that I say grams. For grade 5s, we talked about the volume that would be in these kind of snap cubes. Now, if we had centicubes, which I didn't have this year, it would be, centicubes have a volume of 1 centimeter cubed. And if I fill this up with water, it would be 1 milliliter. And 1 milliliter of water weighs 1 gram. The cubes we worked with are this shaped. And they are 2 centimeters by 2 centimeters by 2 centimeters. So they have a volume or capacity of 8 centimeters cubed, or 8 milliliters. And if I filled it with water, if I filled it with water, if I could, it would weigh 8 grams. And there could be some problems where I'm going to dump these into some water, and you're going to tell me maybe how much they, what the volume is or something like that. Let's take a look at some of these things here. How much do you think how much should a 500 milliliter water bottle weigh? Well, 500 milliliters of water will weigh 500 grams. And then I need the volume, the weight of the bottle, which I don't really know. Let's say it's 20 grams. So that means it could be something about 520 grams. In my can, of bubbly. It is 355 milliliters. So that should be 355 grams plus the can. I don't know, let's say 30 for the can. So 385 maybe for the can. And that's pretty well it. Boys and girls, that is a review of the review math thing that we did today. If you're looking for other work to do, there's always the workbook I gave you, and there's always the review sections in the chapter to look at. Anyways, that's it. Good luck. Talk to you later.